In the future, we will have to move from A to B in a greener way because of climate change. In the case of cars and buses, we are already pretty well ahead in terms of technology, with trains anyway, but green airplanes are really a huge challenge and we are still at the very beginning. What could the aircraft of the future look like? What materials would it have to be made of? How will it be powered? Can flying ever become green at all? Aviation is responsible for 3.5% of man-made climate change. Not only CO2 plays a role, but also substances such as nitrogen oxides, water, steam, and soot particles contribute significantly to global warming. Of course, 3.5% doesn't sound that much. By 2040, however, twice as many people are expected to be flying as today. CO2 emissions alone will triple by 2050 if nothing changes. Commercial aviation in particular will have to change, like our passenger planes to Europe or Asia, but also the air transport of cell phone spare parts from China to the USA. Many companies, governments, and organizations have launched initiatives to make flying more sustainable. Air traffic in the EU, for example, is to become completely climate neutral by 2050. Unfortunately, it is not yet known exactly how this will be achieved, but there are many approaches. Kerosene is the fuel with which most aircraft are operated. Our aircraft of the future should use less or ideally not at all. To achieve this, it would have to be made of very light materials. The lighter the aircraft, the lower the fuel consumption. After all, less weight has to be lifted into the air. In addition, we could try to make individual parts of the aircraft more aerodynamic. After all, we want to glide through the air as smoothly as possible. We can divide the airplane into its many areas and components and try to optimize it. But couldn't we completely rethink the current aircraft shape? In conventional airplanes, the two large wings serve as airfoils and generate lift if you move them forward fast enough. The fuselage doesn't generate any lift and is virtually pulled up with it. This consumes a lot of fuel, so why not just leave out the fuselage? Perhaps our aircraft of the future will be a so-called blended wing. These include the FlyingV concept from TU Delft or the Maverick model from Airbus. In blended wings, the entire aircraft is an airfoil and generates lift. This could reduce fuel consumption by up to 20%. The wings could be used to carry passengers and cargo. Blended wings are significantly more aerodynamic than conventional aircraft. At the same time, however, the shape makes them more difficult to control and stabilize. So again, a compromise would have to be found. In addition, the infrastructure for such aircraft is lacking. Airports have to be rebuilt on a large scale and all that just for the blended wings. But not only that, it is also extremely expensive and difficult to develop and build new aircraft in this size order, so it's quite doubtful that blended wings will catch on. Aircraft, even in their current form, are becoming more efficient and use less and less fuel. With lighter materials, more aerodynamic designs, and optimized engines, the conventional design may be able to get 20% or even 30% fuel out. But then the technology will probably reach its limits. Well, that's probably not enough. Remember, twice as many passengers in the next 20 years, unless of course we switch to another fuel. The car industry is focusing on battery-powered electric cars. Experts are saying for short distances and very few passengers, electric planes could be a solution. Companies like Eviation and Lilium are among the promising manufacturers of smaller aircraft. The Lilium jet is able to take off and land vertically and fly up to 155 miles per hour. The LS jet from Eviation is supposed to be able to fly even further distances. But it will probably not be possible to fly from Los Angeles to Paris. It is possible that airplanes will never fly completely electrically over long distances. Batteries are still far too heavy and not nearly powerful enough to keep passengers' planes weighing tons in the air for hours. The batteries for a passenger aircraft like the Airbus A320 would have to weigh over 50 tons for a 20-minute flight. With the batteries alone, 2/3 of the maximum takeoff weight would already be reached. For longer distances, however, at least hybrid aircraft could be used. These would be powered partially by electricity and partially by kerosene. The two largest aircraft manufacturers, Boeing and Airbus, also seems to be backing this. Hybrid aircraft could significantly reduce fuel consumption. The electric engines would be used primarily for takeoff and landing, and also to produce less noise so that night flight bans in Europe, for example, could be removed. The fuel could also be based on plants, organic waste, or algae. So-called biokerosene produce fewer pollutants such as soot particles when it's burned. In addition, only as much carbon is emitted as was previously absorbed by the plants. This would still affect global warming since the CO2 is emitted very far above the earth, but it's definitely greener than kerosene made from petroleum. Unfortunately, production is very complex and expensive. Mass production is not foreseeable. It would also require an extremely large amount of land for cultivation, which could mean less land for food. Many experts see more potential in hydrogen produced exclusively with electricity from renewable sources. Even if that is still a long way off, hydrogen is much lighter than batteries. Unfortunately, however, quite a lot of energy is lost in the production process. The fuel also requires much more space than kerosene. The huge tanks would have to end up somewhere in the fuselage, where space for passengers and cargo could be tight. In addition, hydrogen in its liquid state must be stored in an extremely cool place, which would also be very complicated and expensive, not only on the plane but also on the ground at airports. You would need a whole new infrastructure. Aviation is facing a gigantic task, and somehow we still don't know exactly where the journey will take us and whether we can achieve climate neutrality. We have only looked at the technological side here. Higher emissions prices and stronger policies could probably make a lot of difference as well. Of course, the problem would also be smaller if we flew less. Flying to Europe every year might not be necessary, and flying within the US may not always be necessary. On top, it shouldn't be cheaper to fly than to take the bus or the train. Don't forget to subscribe. Thanks.